All right, let's dive into one of the biggest, baddest mysteries in the entire universe, the black hole. I mean, these things really push the limits of what we think we know about space, time, you name it. But to really get a grip on them, we have to start by questioning something we all take for granted.
And that's this. Is gravity really a force? I mean, we all learned it in school, right? Gravity's the force that pulls an apple to the ground. But what if that's not the whole story? What if it's not even close?
Yeah, what if gravity isn't a pull at all? What if it's something way, way stranger? Something that's literally built into the fabric of reality itself? That's the rabbit hole we're going down today.
So to really wrap our heads around this, we have to talk about bending space and time. And look, I know this sounds like something straight out of a sci-fi movie, but this is the real deal. This is how the universe actually operates, thanks to the genius of Albert Einstein.
Okay, so here's the core idea. Einstein figured out that space and time, they're not two different things. They're actually woven together into this four-dimensional fabric called space-time. Just picture it like the grand stage where everything in the universe happens.
Now, to make this a little easier to picture, let's use a classic analogy. Imagine space-time as a giant, cosmic rubber sheet stretched out tight. When there's nothing on it, it's perfectly flat. But that's where things get interesting. Because as soon as you put something with mass onto that sheet, say a bowling ball, what happens? It creates a dip, a curve. The heavier the ball, the deeper the curve. Well, it's the exact same thing with planets and stars. They literally create curves in the fabric of space-time.
And here's the punchline. If you roll a little marble nearby, it doesn't just go in a straight line, does it? Nope. It follows the curve made by the bowling ball. And that, right there, is gravity. It's not some mysterious force pulling the marble. It's just the marble following the bend in the fabric. Mind-blowing, right?
This dip, this curve in space-time actually has a name. We call it a gravity well. You know, the sun creates this massive gravity well, and that's what keeps Earth circling around it. And Earth has its own smaller well, which is what keeps the moon and us stuck to it.
So let's put this into perspective. If Earth's gravity well is just a little dimple in that rubber sheet, and the sun's is a pretty deep basin, then what's a black hole? Well, a black hole isn't a dimple or a basin. It's an object so unbelievably dense that it punches a hole straight through the sheet, a bottomless pit in space-time itself.
Okay, so we've established that a black hole is basically an infinitely deep well in space-time. So, what happens if we get close? Let's take a little trip to the edge of the abyss and talk about its most famous and most terrifying feature.
This is the event horizon. Now, it's not a solid surface or anything you could, knock on. It's a line, a threshold in space. On one side of this line, you can still get away. But if you cross it, that's it. Game over. There is absolutely no coming back.
It really is the ultimate one-way street in the entire universe. The moment you're past that event horizon, it doesn't matter which way you turn. Every single path, up, down, left, right, they all lead to one place, the very center.
So what exactly goes down at this cosmic ledge? Well, this is where physics gets really, really weird. For you, watching from a safe distance, if something fell in, it would look like it was slowing down, slowing, until it just freezes at the edge, fading away forever. But for the thing actually falling in, its journey is far from over. It's just that the speed you'd need to escape is now faster than the speed of light. And, well, nothing is faster than light.
So, okay, we can never actually see what's on the other side of the event horizon. But our theories, they paint a pretty terrifying picture. Let's imagine we're taking that journey into the abyss, because the forces that take over are just extreme.
See, the gravity of a black hole is so intense, it doesn't pull on you evenly. Imagine you're falling in feet first. The pull on your feet would be way, way stronger than the pull on your head.
And this incredible stretching force has one of the best names in all of science, spaghettification. Yep, it's exactly what it sounds like. You'd be stretched vertically and squeezed horizontally, just like a piece of spaghetti, until you're pulled apart atom by atom. I agree, not the best way to go.
And once you're, spaghettified, all that matter. Whether it used to be a giant star or, it just keeps going. It all spirals down to the very center, where it gets crushed into a point so small it has zero volume but infinite density. Try to wrap your head around that.
That point, that's the singularity, and this is where science basically throws up its hands.
All the rules of physics, everything we know about space and time, it just stops working. It is the great unknown at the heart of the cosmos.
So, with all this talk of spaghettification and crushing singularities, it's pretty easy to just write off black holes as agents of destruction, right? But that's a huge misconception. In reality, they are way more important. You could even call them cosmic architects.
Yeah, they're not just giant vacuum cleaners floating around gobbling everything up. They actually play a super active, really vital role in building the universe that we know and live in.
Honestly, they're crucial. Take the supermassive black hole at the center of our own Milky Way. It's like a gravitational anchor that holds our entire galaxy together. And the crazy amounts of energy they blast out can kickstart the birth of new stars, and even fling the heavy elements needed for life all across the universe.
All right, so let's do a quick recap of the big ideas. Number 1, gravity isn't a force, it's just the shape of space-time being bent by mass. Number 2, a black hole is so dense it rips a hole in space-time, making a gravity well that has no bottom. And number 3, the event horizon is that ultimate point of no return.
And that leaves us with one last, mind-bending question. At the singularity, where our physics just falls apart, what's really there? Some wild theories suggest it's not just a dead end. What if it's a white hole, a doorway to another place, another time, maybe even a whole other universe? The honest answer is we have no idea. And you know what? That incredible mystery is exactly what makes them so fascinating.